Friends, welcome to this new video on the comparison of the unified performance-based design method and Codal design method. This is a combination of 4 videos. This series comprises of 4 videos together. So videos are like this, done previously. Damage index was studied in video number UPBD 24. Fragility theory practical part was studied in UPBD 25. Fragility numerical part was studied in UPBD 26. And today's is the UPBD 27, where we are comparing all the things together and arriving at the conclusion which method out of UPBD method and Codal method is a superior one. For the purpose of comparing the Codal method and the UPBD method, we have taken a series of buildings. The buildings are like this. We have taken 3 plans, plan 1, plan 2 and plan 3. The plans are rectangular, regular, and we have taken 3 height categories, 5 stories, 7 story and 9 story. So in combination you get 9 buildings. So the way of making is like this. We design the Codal buildings through Codal procedure. Taking the Codal design spectrum, we have taken IS code method here. IS code spectrum, and the member sizes etc. are derived such that it is economical as well as not unsafe. So building nomenclature is like this: C for Codal building, U for UPBD building. Say for example, if it is C25, it indicates Codal building with plan 2 and number of stories 5. So this way we have given nomenclature to all the 9 buildings of the Codal category. For the Codal buildings, the nomenclature is like this: total 9 buildings, and the column sizes and beam sizes along the long and short directions are shown in millimeter. These have been obtained through iterations in the design such that it is neither unsafe nor oversafe, and it is economical. So minimum sizes required to make it safe has been taken. The member sizes of UPBD buildings are obtained of course through UPBD theory. That is, beam depth is to be obtained through the UPBD formulation from the formula and from the chart, from the graph. So the column sizes and the beam sizes in long and short directions are shown here. The depth of the beam is obtained theoretically from the UPBD method. The width is taken, say 1/3 to 2/3 of the depth, which is the practice. The time periods of the buildings are shown here to have a feel of the dynamic properties. The Codal buildings, long direction and short direction time periods, and corresponding UPBD buildings in the long and short direction. If you note here, the Codal buildings time periods are lesser, 0.57 corresponding here 0.84, 1.24 corresponding building is 1.3, and in all cases like that. So it indicates the Codal buildings are stiffer than the UPBD buildings. The performance level of the buildings are obtained either by pushover curve or also can be obtained from time history at the last step, seeing the hinges. So in the pushover, we have 4 types of pushover analysis to be done along the long direction, along the short direction. One is mode proportional load, another is uniform load. So in totality, you require 4 pushover curves to be drawn for each building. Now in the pushover curve, you can mark the different points. This black diamond is the performance point, and the white diamond is IO point, circle is the LS point, and white rectangle is CP point. So take up any building, say this building. What is the performance level of this building through pushover analysis? You note the performance point. This black point is here, and beyond that we have the LS point. So the performance point displacement is less than the LS displacement, so it is a LS building. So this way if you study, and you have to report the worst case out of all the 4 curves. Doing this, you see that all the buildings show LS performance level in the Codal design. This can be also assured from the time history analysis. We have taken typical frames at the last step of the time history analysis where hinges are formed. So the pink colors are the IO performance levels and blue colors are the LS performance levels. So it is seen that all the buildings frames here have developed the blue color hinges, so this LS, which is matching also our observation in the push wire analysis. Now drift, for getting interstory drift, you need to run the time history analysis from the displacement histories of all the floors along any particular direction. You take up the displacement at any instant of time in the upper floor and lower floor, find the difference between these two, then divide by the story height. That gives you interstory drift ratio. You multiply this by 100, you get the interstory drift ratio in percentage, which is called IDR. So for different typical buildings, we have shown 6 buildings I have shown here. This maximum value is the maximum drift you have to report. And these drifts have been obtained out of 11 time history analysis run along both the directions. And the maximum one has been reported here. The long directional values are shown by dotted lines, and firm lines show the short directional drifts. Whichever larger along the long and short is the drift of the building. So this performance of the Codal buildings are summarized here. The nomenclature of the buildings, performance level, we have seen all LS performance levels, and drift shown in the different diagrams have been numerically put here. These are the drift values in percentage. And we have taken the weight of the concrete in beams and columns. For the two series of buildings, Codal building and UPBD building, we have considered the slab is same. The weight in the slab is also same. The infill weights are same. Foundation system is rigid and same. So only difference that is made in the material is in the concrete beam and column. So in the concrete beam and column, the weight of concrete is proportional to the cost. The cost index may change from time to time, so we have not gone to the rupees value, but we have taken the weight of the concrete here directly. Similarly, weight of the steel in beams and columns also have been taken and put in kilonewton. So at any instant of time, the cost of concrete has certain value, cost of steel has some other value, and it changes from day to day. So instead of comparing the cost in currency, we have taken the comparison in material. In this table, we have taken the target objectives for the UPBD building. Target objectives of the UPBD buildings are the performance level shown by the Codal buildings and the drift shown by the Codal buildings. I want to design UPBD buildings for these performance levels, for these drifts, so that the platform for comparison is same. Both are showing similar performance. And now what are the comparison in terms of damage index, in terms of fragility, in terms of cost. So our target performance objectives are LS for all buildings, and drifts are shown here for different buildings. Now after designing all the UPBD buildings, and this table is for the UPBD buildings only, the achieved performance are all LS, so it is satisfying the target. Achieved drifts are like this, which are a little different from the target drifts. How much difference is shown here as deviation. In such studies, deviation to the extent of plus or minus 15% is said to be tolerable. So here it is much less, say 2.5% to 5.9% only. Negative shows the achieved is lower than the target, which is a better condition. And positive shows achieved is slightly more than the target. So the targets are satisfied. So the two categories of buildings, C1 5 to C39 and U15 to U39 are having the same performance level and drift. So they are on the performance based platform, they are having same performance. Now the weights of the concrete and steel are of the UPBD buildings are shown here. Now we compare the all parameters. First we compare the damage index. So there are two kinds of damage indices. One is called the story damage index and another is called global damage index. So story damage index is shown here. The Codal buildings are shown by red hashed lines and UPBD buildings are shown by blue hashed lines. And different buildings are taken here. For example, it is 5-story building, 7-story building with plan 1, then plan 2, then plan 1 9-story, plan 2 7-story, and so on. All the 18 buildings I have not shown here, but simple buildings. In all cases, you can see the red hashed bar is longer than the blue hashed bar, showing the story damage index of the Codal buildings are higher than the UPBD buildings. Now let us compare the global damage index GDI. GDI are obtained from the story damage index and the formula we have discussed in previous videos. Here also the red has lines are for the IS code buildings and blue has lines are for the UPBD buildings. Everywhere the global damage index is higher for the Codal buildings. An amount they are deviating from each other are shown here, 15% lower, 8% lower, and so on. And we have considered plan 1, plan 2 and plan 3, 5 story, 7 story, 9 story buildings here. Then let us compare the fragility. We have discussed earlier what is fragility. For any particular PGA value, what is the corresponding value of the probability of accidents of certain state of damage in the system. So if you take any curve, say red curve here, and say PGA is 0.6, so you read here vertically go to the red curve and horizontally wherever you land out, say 0.52. So this building has 52% of chance of damage of this level, red color shown here as moderate damage, when the PGA reaches 0.6 G. So that is the meaning of the fragility curve. Now the curves are shown in different colors. The meaning is blue color is for slight damage, moderate damage is red color, green color is extensive damage, and collapse is the yellowish last curves. The PGA value of the collapse is highest, extensive is slightly lower than that, medium is lower than that, and slight damage it is taking place even at lower PGA. The dotted lines are for IS code buildings and farm lines are for UPBD buildings. Now let us study this comparison. The UPBD lines, which are farm lines, are on the right hand side in all cases. In all cases you can see plan 1 7 story, plan 1 5 story, plan 1 9 story, plan 2 5 story, all curves I have not shown. So the farm line is on the right hand side, indicating the UPBD buildings can take more PGA for the same probability of accidents than the Codal building. So UPBD building will get less damaged or are less fragile than the Codal buildings. In all cases this is valid. UPBD building lines are always on the right hand side. So these buildings are better for fragility. That is, they can sustain higher PGA for the same amount of damage. Now damage states are slight and moderate damage and extensive damage. So depending on the damage type, you have different PGA for the same probability of accidents. For say probability of accident is 40% of that damage state, then for the slight damage, the PGA is 0.2 G. For 0.4%, for 40% of probability of accidents, for the moderate damage, the PGA is 0.45 G, and like that. So this way you can see that all the UPBD buildings are better in fragility. Then let us compare the cost. So cost of concrete and steel we are comparing separately because they have different currency index. So IS code buildings are shown by red bar diagrams and UPBD buildings by blue bar diagrams. Everywhere the red bar diagrams are higher, indicating the cost of concrete is more for the Codal building than corresponding UPBD buildings. Similar diagrams we have drawn for the cost of steel also. So here also IS code buildings are red color diagrams which are taller than the blue color diagrams for the UPBD buildings. So both the cost of steel and concrete are lower in case of UPBD buildings. The average cost reduction is about say 12%. It ranges up to 15% also, 12 to 15%. So you can see that the UPBD buildings for the same platform of performance are cheaper than the Codal buildings. So let us make the final conclusion out of the video. The story damage index and global damage index of UPBD buildings are less than those of the Codal buildings. So the damageability of UPBD buildings is less than the Codal buildings. The fragility of UPBD buildings is less than those of the Codal buildings. The cost of UPBD building is less than those of the Codal buildings in terms of both concrete and steel. So what does it indicate finally? The UPBD displacement based method of design which considers only drift. UPBD method was superior to that in design because it considered two parameters, drift and performance level together. Now after designing the buildings through Codal method and UPBD method for the same performance target levels, we see that the UPBD buildings are always superior in terms of all the parameters, the damage index, the fragility, the cost. Friends, thank you very much for coming with me up to here. If you find the video useful, please subscribe the channel, like and share the video, and put your comments and queries in the comment box. I shall be glad to answer your questions. Thank you.